Every modern Formula One car is a multi-million-dollar rolling data center, operating as the fastest research and development lab on Earth. In 1989, Ferrari introduced this paddle shift mechanism to keep drivers in control at high speeds while protecting the car's internal components. It took just 8 years for Ferrari to move that technology into the F355 road car. Today, those same shifters are a standard feature in everything from luxury supercars to family hatchbacks. This pipeline from the track to the driveway is now being forced to tackle a much harder problem. With transportation accounting for a massive share of global carbon emissions, the automotive industry is reaching a point where its current technology can no longer meet global efficiency demands. To find an answer, Formula One is tying its entire future to the radical 2026 regulations, a rule set designed to force teams to completely rethink what a high-performance vehicle can be. To understand the future of everyday transportation, we have to look under the carbon fiber skin and dissect the ultimate machine F1 engineers are building for 2026. The car is built around an aerospace-grade carbon fiber monocoque, a single-shell chassis designed to protect the driver from the stress of 6G cornering and high-speed impacts. Wrapping that physical skeleton is an invisible digital nervous system. Modern F1 cars pack between 300 and 600 individual sensors, tracking everything from engine heat to aerodynamic airflow. This chart shows live telemetry data teams use to monitor every millisecond. Generating 3 GB per race, it beams to factory engineers in 15 milliseconds. This data feeds digital twins, virtual replicas running billions of simulations to predict tire degradation and exact pit stop windows. This digital twin technology is already moving beyond the track. It is currently being used to help global supply chains and international operators test new ideas and manage risks virtually before they ever disrupt live production. The 2026 power unit simplifies the engine by removing the MGU-H, a complex heat generator with zero road car relevance. To compensate, engineers are tripling the electrical power of the MGU-K to 350 kilowatts. Half the car's total power now comes from this hybrid system. Recharging a battery this powerful on the track requires a new tactical approach, ranging from traditional lifting coast maneuvers to a high-speed harvesting method called superclipping. During superclipping, the car automatically redirects power from the combustion engine to the battery while the driver is still at full throttle. At the end of a long straight, the car harvests kinetic energy while maintaining its aerodynamic advantage. Mastering this level of energy harvesting is creating the battery management software needed to optimize the next generation of high-performance consumer electric vehicles. The final component of the 2026 machine is a mandatory shift to 100% sustainable drop-in fuel. Using zero crude oil, this e-fuel relies on carbon capture, waste, and biomass to create a liquid chemically identical to high-performance petrol. Teams are battling to ensure it matches the 700 kilowatt peak power of fossil fuels, proving sustainable sources achieve the same extreme speeds. Because this fuel is designed as a drop-in alternative, it proves that high-performance engines can operate within a circular carbon cycle that adds no new CO2 to the atmosphere. Looking away from the circuit, the reality of the global highway presents a massive hurdle for carbon reduction. By 2030, an estimated 1.2 billion internal combustion vehicles will still be on the road. The sustainable fuel being perfected in F1 could drastically reduce the emissions produced by those existing cars. This offers a path to global carbon reductions that doesn't require everyday drivers to scrap their current vehicles or wait decades for a total fleet transition. The artificial constraints and millisecond margins of F1 do more than determine race winners. They accelerate the timeline of human technological evolution. Watching 20 cars line up on the grid is, in reality, a high-speed preview of tomorrow's world.